There are many different types of chemical reactions. In order to better understand these reactions, chemists have divided them in four broad categories. And these categories are based on how their products differ from the reactants. The names of these different categories are: first is combination reactions, second is decomposition reactions, and third is single replacement, and the fourth category of chemical reactions is double replacement reactions. Reactions are also classified by important characteristics such as whether electrons are transferred between the reactants, or so this is a type of reaction which is known as oxidation reduction reaction. They may also be classified as acid-base reactions or combustion reaction. In combustion reactions, reactants react with the elemental oxygen, and this kind of reaction involves combustion, or in other words, fire. And another classification is organic reactions. In this section, we will learn about all these four categories of chemical reactions, and also we will discuss about what are oxidation and reduction reactions. Acid-base reactions will be studied in chapter number 9. In a combination reaction, two elements and or compounds come together to form one compound. In other words, two small elements such as A and B, they combine with each other, hence the name combination. So they combine or come together to form a bigger molecule. So therefore, these kind of reactions are known as combination reaction. For example, nitrogen gas combines with oxygen gas to produce nitrogen monoxide gas. Similarly, water can be produced by combination reaction between hydrogen and oxygen, and the product will be water. So this is also an example of combination reaction. Sodium metal reaction with chlorine gas results in a combination product, NaCl. That's also an example of a combination reaction. Decomposition reaction is the reverse of combination reaction. That is, in decomposition reaction, a large molecule decomposes or breaks down into small elements or compounds. So in decomposition reaction, one reactant split into two or more products. The reaction that inflates an airbag, which was described in the beginning of this chapter, is also an example of decomposition reaction. So the reaction in the airbag was sodium azide decomposes into sodium metal and nitrogen gas. So as you can see now, a large molecule is splitting into two small products. So hence this is a decomposition reaction. Another important decomposition reaction is involved in the elimination of carbon dioxide from the blood. In this reaction, carbonic acid decomposes into water and carbon dioxide, and this carbon dioxide is exhaled through lungs, and hence it is removed from the blood. So that's why this is an important reaction observed in biochemistry. Single replacement reactions, sometimes they are also known as single displacement reaction. In this reaction, an element such as A displaces or replaces another element, for example B, from a compound. Remember, so A will always be an element, and BC, so that's an example of a compound. So A will displace B and will take its place and will become AC, and B will be a free element. Example of single replacement reaction is shown here. In this case, magnesium displaces hydrogen from HCl, and it takes its place and becomes magnesium chloride, and hydrogen is free as a gas. The actual image of this reaction is shown here. The wire is a magnesium ribbon or magnesium coil. So these bubbles are hydrogen gas and the liquid is the HCl. So as you can see, magnesium is displacing the hydrogen and hydrogen gas is escaping as bubbles. In double replacement reaction, one atom or group in one reactant, such as AB, will substitute for one atom or group in the other reactant, for example CD, and it results in formation of two new products, and in these two products it will appear that the pairs have switched their partners. So AB has become now AD, and BC has B has paired up with C. This condition can be considered similar to when two couples are dancing and they switch partners. So that is similar situation. So this is also similar case in which the partners are switched. An example of a double replacement reaction can be seen in those reactions in which two ionic compounds react to form a precipitate. For example, potassium iodide reacts with silver nitrate, and potassium will combine with nitrate, and lead will combine with iodide. Resulting products will be potassium nitrate and lead iodide. And in this reaction, AQ means these chemicals are soluble in water, and S means it's solid. So hence lead iodide will be a solid powder. It would appear as a precipitate in in a solution. Similarly, another example is when sodium hydroxide reacts with HCl to produce NaCl and water. Again, in this case, sodium switches partner and combines with chloride here, and hydrogen combines with OH, and OH and hydrogen, so that's HOH, so which is water, and that's the product here. Oxidation and reduction are one of the most important class of chemical reactions. They are also known as redox reaction, where read stands for reduction, and ox stands for oxidation. So together they are called redox reactions. Redox reactions are key to producing energy in biological cells, as well as producing energy in reactions with the industrial applications such as internal combustion engine, batteries, burning coal to make electricity, and hydrogen fuel cells. Redox reactions are characterized by the transfer of electrons from one reactant to the other reactant. So in these kind of reactions, one of the reactants, such as A, will transfer its electron to another reactant such as B, and then they will give some product. Loss of electron is known as oxidation process, and gain of electron is known as reduction process. So for example, in this hypothetical case where A is losing electrons, so we can say that A is undergoing oxidation process. Similarly, B is gaining, therefore B is undergoing reduction reaction or reduction process. As we can see that if one reactant loses the electron, the other one must gain it. So therefore oxidation and reduction reaction take place simultaneously. Hence that's why they are studied together, and that's why they are also known as redox, because they always take place together. So oxidation and reduction always occur together. The mnemonic oil rig will help you remember which process is which. Oil, you can relate oil as oxidation is loss and loss of electron, and reduction is gain of electron. So from oil rig, we can memorize which process is what. So it will help you to remember that oxidation is loss of electron and reduction is gain of electrons. The transfer of electrons is more obvious in some reaction than in others. For example, in this case, we can see a copper metal wire. So this is copper wire is placed in silver chloride solution. And as we can see that something is happening here. So there is some uh, powdery deposit on top of the wire. So this indicates the evidence of some reaction being taking place. So if we write the equation of this chemical reaction, so we will see that silver chloride in aqueous solution is reacting with copper to produce copper chloride and silver. So as such, from this equation we cannot really see who's losing or who's gaining electron and who's losing electron. But if we split this reaction, then the process becomes more obvious. So if we look carefully here, so here in this case copper is a neutral metal. It does not have any charge in the reactant side. However, in silver chloride, as we understand from the ionic compound formula, silver is actually present as a silver positive and chloride is Cl negative. So copper has no charge in the reactant side and silver has a +1 charge. But as we move along to the product side, we will see that in the product side now silver has no charge because it's an element now, so no charge. On the other hand, copper, if you copper has become a part of ionic compound, so it means if we split open, so we will find that copper is a 2 positive charge, and because it is bonded to 2 of the chloride anions. So what's happening in this process is that in this reaction, copper is losing 2 electrons. Once it loses 2 electrons, it becomes 2 positive. So hence, these two this process is oxidation because copper is losing the electron, and these 2 electrons are being absorbed or gained by the silver, 2 silver anions. So therefore, silver positive is becoming silver neutral or neutral metal. So in this reaction, so what's happening is that copper is transferring its electrons to silver. So therefore copper is losing the electron and silver is gaining the electron. And copper is undergoing oxidation and silver ion is undergoing a reduction reaction. So therefore, keep track of these electrons. We divide this reaction in 2 half reactions. So these are called half reactions. And the top one is called oxidation half reaction. And the bottom one is known as reduction half reaction. Another example of oxidation reduction reaction is the reaction between sodium and chlorine gas. And in this reaction, sodium chloride, which we also know as table salt, is produced. In this reaction, 2 atoms of sodium reacts with 1 chlorine molecule to produce 2 sodium chloride formula units. Now, as such, we can't really see who's losing the electron or who's gaining the electron, but if we investigate it thoroughly, we will be able to understand it completely. So sodium metal has one extra valence electron. So this is the valence electron of sodium atom. So we remember we have two of these. So I'm going to write the another one here. And chlorine is a covalent molecule, and they are sharing their valence electrons so that their octet is complete. So as in this covalent molecule, both chlorine atoms are sharing one uh, valence electron so that their octets are complete. So in this reaction, what will happen is that we have two sodium atoms, and first this bond will break. Once this bond will break, it will generate two chlorine atoms. Now these chlorine atoms have only 7 valence electrons around them, which makes them unstable. At the same time, we have two sodium atoms, and they have extra valence electron lying around, which is also making them unstable. So in order for them to be stabilized, what will happen is that this sodium will transfer or donate its electron to one of the chlorine, and the second sodium will also donate to the second chlorine. So after donation, what will happen is that sodium will lose the electron. So I can't erase this one. Okay, so sodium will lose these electrons, and these electrons will be transferred to, let me use different color, and chlorine atoms will gain those electrons. Now loss of electron, we know that now it has less negative parts, so therefore this sodium atoms will become positively charged, and because chlorine atoms have gained the electron, they will become negatively charged, and we know that positive charges and negative charges attract each other, so they will attract each other, and after that they will form Na positive Cl negative, two of them. So it means, well, although I'm showing these charges here, but when they are together, the charges neutralize each other, so that's why we write without the charges. So that's the product. So now it is clear that in this reaction, sodium is losing the electron, and chlorine is the one who is gaining the electron. So therefore, we can say that in this process, electrons are transferred from sodium to chlorine. So sodium is undergoing oxidation, and chlorine is undergoing reduction, and hence this is an example of redox reaction. In the oxidation and reduction reactions of an organic compound, the transfer of electrons is not obvious. We know that organic compounds are those molecules which are mainly consist of carbon and hydrogen atoms. So therefore, in these reactions, it is easier to look for an increase in oxygen or decrease in hydrogen as the indicator of oxidation process. So oxidation process can also be defined as increase in number of oxygens or decrease in number of hydrogens. And opposite is true for reduction. So in other words, reduction is defined as decrease in oxygen atoms and increase in hydrogen atoms. Let me explain with the help of an example. Let's consider the example of combustion of methane. So methane is the gas which we use in the lab or even at home for cooking and or all other kind of heating purposes. Formula of methane is this one, CH4. It's a carbon compound and it's bonded to 4 hydrogens. And when it combusts, combustion is a process of burning of any fuel. So in combustion, basically any fuel, which is methane in this case, combines with oxygen. It's always going to be oxygen. And if our fuel is a hydrocarbon based fuel, then the products will be always carbon dioxide and water. Now in this reaction, because all of these compounds are covalent compound, they are not ionic, so we can't really, they don't have any charges. So if they don't have any charges, we can't really say anything about transfer of electrons, because we don't know who's losing electron, who's gaining electron, because we can only determine if they have some charges. Now therefore in these kind of reactions, it's easier to keep track of oxygens and hydrogens. Let's pay attention to methane molecule. So methane, carbon has 4 hydrogen before the reaction, and after the reaction, let's see what happened to the carbon. So now carbon has lost all the hydrogens and it has gained oxygen. So what do we call the process of uh, gaining or increasing number of oxygens and losing hydrogens? So therefore we can say this process is oxidation. So in other words, carbon is undergoing oxidation, because carbon is decreasing the number of hydrogen from it and increasing the number of oxygens. Let's classify these reactions in different types. So A, in reaction A, it represents AB plus CD. And so A would be silver, B would be nitrate, and C would be calcium, and D is Br. So therefore it becomes A and D, and the other one would be B. No, it would be C, and nitro group is B. And so therefore they are switching partners, so therefore this reaction is classified as double replacement reaction. This reaction, two small elements are combining with each other to produce a large molecule, so hence this reaction is a combination reaction, because it resembles A and B gives AB, so therefore it's a combination. The third reaction is, in this case, AB is splitting into A and B, so therefore this is a decomposition reaction. And finally the last one, so Cl is replacing the Br, so it represents A to BC. So therefore this is a single replacement reaction. Let's take a look at another example. Uh, how can you determine that this reaction is a redox reaction? So let's analyze this. So in this reaction, Cl is a neutral molecule. Neutral means it does not have any charge, because it's a covalent molecule. Covalent molecules don't have any charge. On the other hand, NaBr is ionic molecule, and therefore ionic compound, they always have charge. So in this case we know sodium has a positive charge and Br has a negative charge. On the product side, NaCl is an ionic compound, and we know sodium has a positive charge and Cl has a negative charge, and Br is neutral. Neutral means is no charge, right? So no charge or neutral. Okay, so chlorine is a neutral atom in the reactant side, and in the product side it has a negative charge. So it means if we split this reaction in two half reaction, it means we can write the chlorine from the reactant became Cl negative. Okay, how can a neutral become a negative charge? Only way this reaction is possible is if it somehow gains electron. Now we have two of them. In order to balance it, we need to have two here and then two here. So it means chlorine from neutral to Cl negative, so it must gain electron, and we know if a species gains an electron, that process is a reduction reaction. So therefore chlorine is undergoing reduction. Similarly, bromine is ion in the reactant side. It has a negative charge, but in the product side is neutral. So only way that Br negative can become neutral on the product side if it loses electron. So it means Br negative is losing or giving out electrons. And in order to balance this, we need to have two here and two here. Now it's balanced. And any process where electrons are lost is the oxidation process. Or in other words, we can say that the Br is undergoing oxidation. Now, because in this reaction, both oxidation and reduction are taking place, hence this reaction is a redox reaction. So with that, we complete this chapter. So in this chapter, we learned about the mole concept, and then we also learned about writing and balancing the equation, and finally we discussed types of various reactions. And if you have any question, please let me know, and I'll be happy to explain any concept where you need more help. Thank you everyone for watching the video, and have a wonderful rest of the day. Bye bye.